Hello, I'm Bruce Yaney, and today in Homemade Science, we're going to take a look at an example of an escapement. Now, an escapement is basically a mechanical device that will stop and then release movements in regular intervals. There are literally hundreds of designs dating back to about the 13th century. Escapements can be found in a variety of different uses, but probably the most common use is found in clocks and watches. In larger wall clocks and floor clocks, you'll quite often see it matched up with a pendulum. It's the length of the pendulum that actually determines the rate of the movement. In smaller clocks and watches, instead of a pendulum, the escapement is attached to a balance wheel. Here we can see it moving back and forth. Here's another type of escapement. This one's found inside a piano. Even the alternating movement of this ramp walker's legs can be an example. Now back to our demonstration piece. Now if we take a close look, we'll see that this is a series of simple machines all acting together as a compound machine to perform a simple task. The end result of this piece is the turning of this flywheel. It's powered by gravitational potential energy that's provided by this 4-pound weight. The weight itself has 2 pulleys built into it, and since this weight is supported by 2 strings, that means only half the force gets applied to the string that eventually works its way to the 2 pulleys on the support bar, and then on to the escapement wheel. The escapement wheel actually has 2 other wheels attached to it. The first wheel has 12 teeth cut into it. The second wheel is smaller and has the string attached to it. The third wheel is then larger. It's acting as a guide for the string and is used for winding. By adding extensions to that third wheel, it makes it easier to wind up. The next simple machine in our progression would be a lever. The lever has a locking tooth on it that keeps the escapement wheel from turning until it's lifted up out of the way. The escapement wheel can only advance 1 tooth at a time as that lever falls back into place. We could also identify the pendulum arm as a lever. The lower part of the bar acts as the effort arm. The length of the bar above the pivot point is actually the resistance, and it's transferring energy to that turning wheel. The wheel itself is about 6 inches in diameter, and the force is applied about 1/2 inch from the center. One last note, the wheel turns just as well in either direction. Now, as a teacher, I found pieces like this to be a valuable teaching tool in lessons on energy and forces and work and simple machines and how they're all interconnected. So not only would I have pieces like this sitting around the room, but I'd also have questions that I'd want students to answer. Now, I will list some of those questions down in the description, but now let's go on and take a look at a couple other devices that I found helpful when looking at machines. I've made larger reproductions of common items like this lock. Here are engines that are driven by air pressure. This device will wave 2 flags simultaneously. Large and small catapults have also been very popular. This is called a Tremel of Archimedes. I found students were always interested in seeing how things operate. After taking them apart, they were put on display. It's not even necessary to build things. Just look around, you can find all sorts of examples of devices that demonstrate simple machines. Well, I hope you enjoyed this video, and in part 2, I'm going to show you some basic ideas on its construction.